Being an AI developer now feels like learning and orchestrating rather than coding itself. I've studied the design of the logic for a reasoning agent, and here are the thoughts. The whole week I've dedicated to AI agentic system design, and among thousands of lessons that I've learned, I would like to share only one here, which is the core and main orchestration of agents. The whole idea behind agentic reasoning is built actually upon how humans think, and there are certain stages that the agent has to go through in order to give you an answer. For example, it's not one thing to realize it's not linear. We are not thinking linearly, so it's not a chain, but rather it's going back and forth between stages of our thinking. We do it subconsciously. We don't even notice that on our day-to-day life, and we would hardly notice in any condition all of that. These are actually 6 steps that agents have to go through in order to give you a good answer: clarify, plan, retrieve, design, critique, and finalize. Clarifying refers to obviously asking questions if it is needed. Let's imagine I'm building an AI agent that helps you design system for your project. So the first thing it's gonna do is ask you specifying questions. So the whole stage can be testable, and it can measure what actually are you planning to do. And after it specifies enough questions from you and it has enough of information, it goes to another one. It plans. You probably have noticed that all the reasoning models, they go through your request step by step, and they analyze it, and from that analysis they actually give you the plan. And following that plan, it goes to retrieval. Retrieval stage is when it pulls out the information either from internal database, if you have, for example, some database that you have trained your model on or something in Supabase, for example, or you've allowed it external search like web search. It goes through the plan which it has built from the specifying questions. Now that it has pulled the information from different sources, it designs you, which is the first step of the pipeline, the potential output, which later will need to be evaluated. Evaluation is a big thing. OpenAI actually has released the papers that everyone's buzzing about, why models actually hallucinate, and it's quite complex. I've posted about it on X. This evaluation stage is very important because you measure the output against certain standards, benchmarks and stuff, and it evaluates if this is why it's called critique stage, because it criticizes if it's good enough to satisfy your request or no. And from that critique stage, it then goes ahead to the 6th stage and finalizes, wraps it around in a beautiful paper and gives you the output. And the beauty of that is that it's not linear. It's not going like a chain in one way and cannot get back. It actually can, because if you look at graphs, for example, a very good tool that I am learning right now and I'm trying to implement in my project, which is a LangGraph, very popular one. And with LangGraph, it's very easy to implement that. So one thing is LangGraph, very important tool in a whole tool set as an AI developer. System design is designing how different multiple components interact. And traditional system design asks a question like, how should components like databases, queues, caches, APIs, etc. interact so that they meet requirements in a context of scale, reliability, etc. In agentic case, your components are cognitive stages like clarifier, planner, designer, retriever, etc. You're orchestrating them, you're deciding flows, you're getting feedback, and doing the stuff, deciding on the evaluation gates and doing the other stuff. One thought that I also had this week is that AI development is actually a very broad term, and AI development is comprised of ML engineering, ML ops, and orchestration. Knowing how ML engineering work equals like to the idea of knowing how to build, how to craft something. This is a craft space. Imagine you're a car builder. You know how to design a car, interior, exterior, you know how to get the engine together and stuff. But when it comes to the time when that car breaks and something, falls apart, you need to assess how and what the hell has happened to this car so I can fix it. And this is where ML ops get into the game. That if you've the point I'm trying to make is if you have mastered ML engineering, the craft space, ML ops is literally maintenance space. It's when you know how to maintain the systems that you have built. And so basically, if you've learned ML engineering deeply, the next possible really step and the most sensible one is getting into ML ops, which is another skill that will help you in your AI building.